So today we are discussing IPv4 addressing. So IPv4 addressing, IP addressing is the logical addressing. It works a network ID layer 3 protocol. It version of addressing scheme. The versions are two types. One is IPv4 addressing and IPv6 addressing. One is IPv4 addressing 32-bit addressing and IPv6 addressing is 128-bit addressing. IPv4 addressing is the 32-bit addressing, 32-bit addressing, and uniquely and universally defines the defines the connections of the devices. So, for example, of a computer or router in the internet. IPv4 addressing is the unique and the universal, and IPv4 addressing is the 32-bit long we are using. The address space is IPv4 is 2 power 32-bit we are using for the notations. Notations are binary notations and the dotted decimal notations we are using presents. Here notations are we are using for this one notations, and this is the decimal dotted notations. IPv4 addressing here what is bit? Bit value. Bit is a value. It will represent the zeros or ones we are using for this one. This is the zeros and ones represents. That is the binary formats we are using bit. So the 32 bits divided into 4 octets is known as the decimal notations or we are using for this one. This is the first octet, second octet, third octet, fourth octet we are using represents. And the binary to decimal conversions. Taking an example for the first octet, the total of 8 bits, the value will be zeros and ones we are using. That is 2 power 8, 2 power 66, 256 combinations are we are using for this one. Zeros and 256. The total IP address range is 0.0.002, 255.255.255 we are using the range. Here the classical addressing. Here classes is divided into 5 classes we are dividing. So this is the one is the binary notations. Class A range is 0, class B range is 1, and class A range is 2. We are using for the notations we are using for this one. And class D, class E. Class A range is 0 to 127, and class B is 128 to 197. Class C is 192 to 223. Class D is 254, 224 to 239. Class E is 240 to 255 we are using for this one. This is the Class A IP addresses. The IP addressing scheme is divided into 5 classes. So 5 classes we are using Class A, Class B, Class C, and LAN and WAN we are. Here these are 3 classes are using the LAN and WANs. Class D is multicasting and network groups we are using. Class E is research and development tool. So we are using for this one. These are the classes and blocks we are using. The classes classful addressing base is the large part of the address space we are using. So class A, class B, class D, class C. Class A range number of blocks 128. The block size is this one, and the application is unicast. Class B is number of blocks 16,384. Block size is 65,536. It is using the unicast we are using. Class C, this is the block size is 254. The application is unicast we are using. Class D, Class E is 1. This is the range block size. This is the one is using the multicast. Second one is using for the reserved for the classes we are using for this one. Reserved for the classes we are using for this one. And the structure of IPv4 addressing. So structure, this is the structures. Binary notation, Class A, Class B, Class C. These are the binary notations we are using. And the dotted decimal notations are 255.0.02. This is the dotted decimal CSIDR, and we are using the host number of hosts we are using for this one. So we are using the networks hosts we are using for this one. Networks we are using for this one. And mask, 32-bit number of contiguous ones followed by continuous zeros to help the find with the net ID and the host ID we are using for this one. So we are using for this one. Use of the IPv4 addressing, we are using the subnetting. What is subnetting? Subnetting is divided. Subnetting is divided into large address space into smaller groups. Use of flexible net mask we are using. Supernetting executed a class A, class B address space. Huge demand for the huge demand for the class B address space we are using to combine the several continuous address space into a large single address space we are using for this one. And priority bit concept we are using to identify the range of each classes. We will using the priority bit concept we are using. Priority bit is the left bit in the first object. Class A is priority bit 0, class B is 10, class C 110, class D 310, class E 410 we are using. These are the priority bit we are using for concept. These are the class A for range is reserved for the bit to the first octet. The value should be the range and zeros. This is the 2 power 0 to 2 power 7 to 127, 0 to 127. It is the reserved for the zeros and 127 for the reserved for the network or reserved. And this is the class B. This is reserved. We have to 0 to 127. We are using for this one. Next one is the class B. The 4 octet and the value for the 102 octets are reserved. The range is 128 to 197. The ranges we are using for this one. This is the class C. Class C reserved for the first bit, first octet. The value should be not be changed. 31110. We are using for this value should not be changed. Here 192 to 223 bit we are using for this one. And the class D range is first 4 octet. The value should not be changed. Here we are using for this one 224 to 229. And this is the class D. Class E range 4 ones 0 to 257. 4 ones are not be changed. 240 to 255 we are using for this one. For octet, octet format is we are using for this one. It is divided into network hosts. The partition class A is written as one network, 3 hosts. Class B written as two networks, 2 hosts. Class C 3 networks and one host we are using for this one. So class A network, so we are using for this one. Class A is one network, 3 hosts. Class B is two networks, 2 hosts. Class C is 3 networks, 1 host we are using for this one. Class A, number of networks, number of hosts. So here, one network is 8 bits, 8 networks, hosts is 24. Number of networks, we are using 2 power 8 minus 1. Minus 1 is the priority bit. We are using one network is priority bit. 2 power 7 minus 28. 2 or zeros and 1 or 127 are networks. These are the reserved. So 126 bits networks. So we are using the two number of ports, 2 power 24. Minus 2 is the network ID and the broadcast ID we are using for this one. This is the class B range. Two networks, two ports. So 16 bit, 16 bit. Number of network 2 power 16 minus 2. Minus 2 2 power 14. We are using number of ports. So 2 power 16 minus 2. We are using 65,534 ports and networks we are using for this one. This is the class C range. This is the class C range. Class C format is 3 networks and 1 host, and network is 24 and host is 8 bits. It will be used for 2 power 24 minus 3, 2 power 21. So this is the network. So number of ports, 2 power 8 minus 2. One is network ID and the broadcast ID, 256 minus 2. We are using a 256, 4 we are using for this one. What is network? What is host? What is network? What is host? The network address is the represented with the bit as 0 in the host partition of the address. The network address represents the host bit as 0 in the host partition of the address. The broadcast address is represented with the all bits as ones in the host partition of the address. And the valid IP address that is between the network ID and the host ID we are using. Only valid IP address are assigned in the host or clients we are using for this one. This is the example for class A. One network, one host. So one network ID, zeros and zeros, three networks. Class A range, one network ID, broadcast ID. These are the between, so 10.0.1 to 255.254, the valid IP addresses we are using for this one. This is the class B. Two networks, two hosts. This is the network ID address. This is the broadcast address. The class B range is 172 is the network ITP address. 172 is the broadcast IP addresses. So 172.1.0.16.0.1 to 255.254 the valid IP addresses we are using. This is the class C. Class C is three networks, one host. This is the broadcast address 192.168.0.0 one network ID. This is the 192.255.252 the broadcast ID. 068.0.1 to 254 valid IP addresses we are using for this one. Loopback address. Loopback address is the special IP addresses. It is reserved as the loopback for your own computer, and range is 125. Range is 127.0.0.0. It is used for testing, debugging on your program hardware we are using for this one. What is subnet mask? Subnet mask is a differentiates between the partition and the host partition. Network partition and the host partition. Subnet mask is between host identification of the network ID. Represent all network bit values with 1. Represent all host bit value with zeros. We are using 1. Zeros and 1s, so we have to represent. Network bit no represent, host bit no, we are represent 0. This is the example subnet mask. Class A one network, three hosts, three ones, and the host is represent 0. Default subnet mask is ones represents 255 network ID, host 0. Class B two networks, two hosts, one ones, 0 0. We are using for this one 255 255 0 class C. So so range we are using for this one. APIPA address range, one is APIPA and is private IP addresses, and one is uh, represents the public IP addresses we are using for this one. So these are the IPv4, IPv6 differentiate between the address 32-bit address, 128 bits, packet sizes to 576 byte recorded, fragmentation optimal, fragmentation 1280 bytes required without fragmentation, packet fragmentation, router and the sending host only, packet header does not identify the packet followed by the QoS handling, contain the flow label field we are using for this one, and does not included in the checksum, and DNS records address we are using, address space also we are using, and the address is we are using for the names, address space of configuration manual IP at DSCP flags using the internet control and managing the protocols versions we are using version 6. IP to MAC resolutions, broadcast ARP, multicast neighbor solutions. Address configuration manual or via DSCP. Stress and DSCP act we are using the slash IPv4 addressing. Local subnet mask we are using. These are the IPv6 addressing. These are the IP addressings we are using for this one.